All right, in Chapter 10, we're going to look at what happens when you have two samples, and we're going to start by comparing two proportions. Okay, so what are the conditions for calculating a two-sample interval for P1 minus P2, P hat 1 minus P hat 2, the difference of two proportions? Well, the first one is random. Are the samples random or random assignment experiments? You just have to check both. That's the only change here. Then you have to check the independence condition. Is the sample 10%, less than 10% of the population? You just have to check both samples again. And then large counts. Is n times p greater than 10 and n times 1 minus p greater than 10? You just have to check both samples. That's the only change here. You have to just double your work in some ways, but it's not that bad. Same three criteria. Then what's the standard error of the difference of two proportions? And how does this differ from the standard deviation? All right. So the standard error of the difference of two proportions looks like this. Notice previously our standard error was just basically this one fraction here. But now we have two samples, so I have to do it for each of them. And then I add them, then I take the square root. All right, so how is that different than standard deviation? Well, in standard deviation, we don't use p hats. We use the true proportions, okay? So this is what we're going to use in our confidence interval, because all we have to work with when we're doing a confidence interval is a sample proportion, or a p hat. And this measures how far a sample proportion difference will typically vary from a population difference in repeated samples. So then what's the formula for a two-sample z interval for the difference of two proportions? Well, here it is. It looks a little crazy, but it's really the same as what we've done before. We just added a second sample. All right, so here's our two sample proportions. Here's the plus and minus. Still have z star in there. We find that the same way we did before. And then we have the standard error formula right here. And we just discussed that you just have to do both samples and add them before you take the square root. Now, here's the good news. The calculator will do most of this for you. The bad news is it's not on the formula sheet. All right, but that's okay, because when we're doing two samples, it's really just easier to use the calculator. And I'll demonstrate that in a little bit. All right, so let's look at this example. Have opinions changed about gun control? Gallup regularly asks random samples of U.S. adults their opinion on a variety of issues. In a poll of 1,011 U.S. adults in January 2013, 38% responded that they were dissatisfied with the nation's gun laws and policies, and they want them to be stricter. In a similar poll of 1,011 adults in January 2012, only 25% agreed with the statement. So it looks like the proportion has increased, right? Well, let's just see. Explain why we should use a confidence interval to estimate the change in proportion rather than just saying that the percentage has increased by 13 percentage points. Well, it's because of sampling variability. We've discussed this, that one sample may be different than another. So I've taken one sample from one year, one sample from the next year, and those two samples indicate an increase, but that may not be exactly correct. I'd have to do it over and over and over to know for real. So because of that, I just do a confidence interval to give me a range of values that it could be. So part B says, use the results of the polls to construct and interpret a 90% confidence interval for the change in the proportion of U.S. adults who would agree with the statement about gun laws. All right, so we're going to do the state, plan, do, conclude thing. All right, so let's see. We want to estimate the difference of proportions. That's what this is showing you right here, where P13 is the proportion of U.S. adults dissatisfied with gun laws in 2013, and P12 is the proportion of U.S. adults dissatisfied with gun laws in 2012. And it's okay to use those quotes, you just need to differentiate it. And make sure your labels make sense and you've kind of explained what it is. This is the defining the parameter step we always do. And we put in how much confidence do we want to use. Well, we want to use 90% confidence in this question. Okay, on to the plan step. So we're going to construct a two-proportion z interval if the conditions are met. So remember, we have to name the test we're using. Then we're going to have to go back to our question and decode all the values in here. So let's look at this. The first sample was 1,011 U.S. adults in 2013, and 38% responded that they were dissatisfied. So they gave us the p-hat and the sample size. So p-hat of 13 was 0.38, sample size was 1,011. Then in 2012, the sample size was the same, but the p-hat value was 25% or 0.25. So I'm going to use those values as I check conditions. First of all, random. Are both samples from random samples? Yes, it says they ask random samples of U.S. adults their opinion on issues. So we assume it goes to both samples. All right? And they're 2 different years, so they are independent. 10% rule. Okay, if you notice, both samples are the same size. So is 1,011 less than 10% of all U.S. adults in 2012 and then in 2013? Yes. So we've shown that that's independent. And then we do large counts, and we do it for each proportion. So the first sample, 1,011 times our p-hat, 0.38, gives me this. 1,011 times the complement gives me this. Then I do the second sample of 25% and the complement of 75%, and I get this. So then I need to add in what's the boundary we're looking for. Well, all of these are greater than or equal to 10. You always need to mention that. So the large counts test is satisfied. If you just put the answers here and don't put the boundary of 10, greater than or equal to 10, you'll lose points, so be careful with that. All right, so here's the formula we talked about before. So I'm just going to plug in the numbers that I know, all right? So P1 was my P13, P-hat 13, P-hat 12 right here, plus or minus, and then Z star, okay, it's a 90% confidence interval, so I drew out my confidence interval. I found 90% is in the middle, and I found my inverse norm value of 1.645 like we've done in the past. And then I, again, plug in the correct values into this formula. I crunch the numbers, and then I end up with this interval here. So I need this interval to make my conclusion on the next slide. Okay, so here's the interval. Now, how do I make a conclusion about a confidence interval? We say we are 90% confident that the true proportion change in adult opinions of gun laws from 2012 to 2013 is between 0.096 and 0.164. All right? So that's how we interpret the confidence interval. So look at the next question. Based on this interval, is there convincing evidence that the opinions about gun control has changed? Well, if it hasn't changed, then the two proportions would have been exactly the same, and when you subtract them, you would have 0. So the way you know if it's changed, you look to see if 0 is in the interval. Well, both of these values are greater than 0, so 0 is not in there. So that's good evidence that there has been a change. So all we can say is yes, because 0 is not in the interval, there is convincing evidence of a change in opinion from 2012 to 2013. Okay, don't ever just say yes or no. Make sure you defend your answer using the interval given. Okay, so can you use the calculator for the do step? Absolutely, and you're going to want to because it's a big time saver on these time tests. So you're going to use stat test B. It's 2 proportion Z interval. Don't use the 2 sample Z interval. Make sure to use the 2 proportion Z interval. Now, there are some drawbacks because students get tripped up on this a lot. You have to find X. And X is an integer. It's not the p-hat value. Here's what I mean. P-hat is a ratio of the individuals with a certain outcome divided by the total sample. Okay? So X represents a whole number. It's an integer. So if I don't know what X is, that means the question gave me the p-hat and the n value only. So if I just algebraically rearrange this for X, that's just p-hat times n. And if you remember, with the large counts test, we do n times p-hat, right? It's the same calculation. So if they, for some reason, don't give you the X value, and you need it, go back to the large counts test and look at what you first did. So here was our sample, here was the first p-hat, and I got this value. Now, obviously, it's a decimal. So when I put it in my calculator for X, I need to round it to a whole number. Okay, so let me show you. My X1 was 284. I rounded it to 284. There's my sample size. My X2 was the second sample when I did the n times p-hat. I round it to a whole number at 253. And then sample size, and I adjusted my confidence level. When I hit enter, then it generates the p-hat values for me, and there's my interval at the top. So it's a big time saver. So as far as work on your paper, you need to show what p-hat 1, p-hat 2, n1, n2 is, and your interval. It's even better if you can show me x1 and x2. All right, so that's the biggest place students mess up, is they try to put in, like, if they gave you a p-hat of 39%, they try to put in 0.39 for x. That won't work. If you put in a decimal value here, it's going to give you an error. All right, so be aware of that. X has to be an integer.